Hello! So this is the last part of the 2013 edition of the MIT Integration B Solutions, which I am doing. So for this video, I will be solving the last 7 items 19 to 25. If you haven't checked it out, I highly suggest you try first, or you watch first my first 2 videos for this. And these are the problems for those 2. For this video, I will be answering these items. Quite easy, maybe not. Okay, let's start for number 19. It's the integral of dx over 2 minus 2x plus x squared. You have a quadratic term in the denominator, so it gives you a hint that it has something to do with trigonometric substitution. So to do that, we have to express this 2 as something just something x squared. By completing the square, that's equal to 1 over 2 minus x squared plus 2x. Sorry, that's plus, then minus. So what we do is a plus 1 minus 1. To make this a perfect square trinomial, I put the minus 1 here. So I get 1 over 2 minus 1 plus, this is x minus 1 squared. So this is 1 plus x minus 1 squared. So we are looking for the integral of dx over 1 plus x minus 1 squared dx. Okay. So this is quite straightforward now. If you use the substitution u equals x minus 1, du equals dx, this becomes du over 1 plus u squared, whose integral is very, very popular. And it's equal to tangent inverse of u plus c. So the answer is tangent inverse of x minus 1 plus c. Done. Next. Item number 20. We have the integral of sine x log sine x dx. You have a trigonometric function here. You have a logarithmic function here. So these are perfect hints to use integration by parts. Of course, we'll choose this as the u because we can't integrate that. Okay, so we let u equals log sine x, du is equal to derivative of log, so 1 over sine. Derivative of sine is cosine dx. So this is cotangent x. Anyway, next our dv is sine x dx. Our v is negative cos x. So our our integral is then equal to sine x log sine x dx equals, remember, integral of u dv is equal to uv minus integral of v du. So this thing here is equal to negative cos x log sine x minus negative, so I'll just make it positive after a while. So I won't write it as cotangent x because I want everything just to be in terms of cosine and sine. So cos. So cosine squared x sine x dx. Wow, so this becomes positive. If you've watched my previous video, you'll see that this has already been solved in that video. Anyway, for the purposes of presenting the complete solution, I'll do it again. So I'll split cosine squared as 1 minus sine squared over sine x dx, which is equal to 1 over sine x dx minus sine x dx. This is cosecant x. This is sine x. So the integral of cosecant x is ln of cosecant x minus cotangent of x. The integral of this is negative cosine of x plus c. So the terms we have are this plus this. So the final answer should be negative cosine of x log sine x plus ln, sorry, this should be log, just to be consistent with the notation, log cosecant x minus cotangent x plus cosine x plus c. Whew. Quite long, but maybe not that hard. Okay, next. Item number 21. The integral of x over 1 minus x to the fourth dx. Okay, you have an x to the fourth here, which is equal to x squared squared. So if we let u as x squared, we can get rid of this x in the numerator. So doing that, let u is equal to x squared, du is equal to 2x dx. So du over 2 is equal to x dx. So this integral right here becomes x dx, that's x dx. Then du over 2, I'll factor out the 1/2. And this becomes 1 over 1 minus u squared du. Ho ho ho. And then this one can be expressed in partial fractions. We can decompose this in partial fractions. I leave that up to you because I already know how to do it quick. That's 1 over 1 minus u minus 1 over 1 plus u. Sorry, this will be plus. Then times 1/2. Okay, then this becomes, there's an integral right here, 1/2 times 1/2, so that's 1/4. Integral of du over 1 minus u plus 1/4 integral of du over 1 plus u. Next, if we let, say, k cos 1 minus u, then here w cos 1 plus u, this will become negative, what am I saying? dk equals negative du. So this just becomes 1/4 of dk over k, but there's a negative du here, so this becomes negative here. So this one, on the other hand, is just dw is equal to du. So that's 1/4 plus dw over w. This is negative 1/4 ln k plus 1/4 ln w. What? So we're writing everything back to what we want. This is negative 1/4 ln 1 minus u. The other one is 1/4 ln 1 plus u. There should be a plus c here, plus c. Again, in terms of x, negative 1/4 ln of 1 minus u squared, x squared plus 1/4 ln 1 plus x squared plus c. Wow! Okay, maybe you don't believe me writing this into this. I'll tell you a shortcut. Oops. Whenever there's a shortcut, a bonus for this video, an Easter egg. Okay. So whenever you have u squared, it's called a squared minus b squared. No, 1 over x squared minus a squared. This is always equal to 1 over 2a then 1 over x minus a minus 1 over x plus a. What? Okay, so the shortcut for a further shortcut is, if you get the antiderivative of this, it looks like this. Integral of this is equal to 1/2 of 1 over 2a times ln x minus a over x plus a plus c. Is this a shortcut? So for example, the one earlier, you have du over 1 minus u squared. I want something to be in this form just to make it more consistent. So that's negative of du over u squared minus 1. This becomes negative 1 over 2 times a. This is your a squared, so a is 1. So 2 times 1, ln x minus 1 over x plus 1 plus c. The one earlier is just a decomposed version. You can combine them using properties of logarithm, but essentially that is equal to this one. Okay. Next, item number 22. Integral of the square root of 12 minus 3x squared dx. If you've watched the first video, this already appeared, although it has limits. It's a definite integral. This one is indefinite. So first, what we do is we factor out the square root of 3 times square root of 4 minus x squared dx. So this is equal to square root of 3 times square root of 4 minus x squared dx. So we have a quadratic term in a radical. The best or the most intuitive solution is to use trigonometric substitution in terms of sign. So we let x is equal to 2 sine theta. 2 coming from this one. 2 squared is 4. Then dx is equal to 2 cosine theta d theta. So this one becomes square root of 3 times, there's a factor of 2 here, I'll take it out, 2 square root of 4 minus 2 sine theta squared times cosine theta d theta. Hooray! Simplifying it further, we have 2 square root of 3 square root of 4 minus 4 sine squared theta times cosine theta d theta. If you factor out the 4 here, 4 times 1 minus sine squared theta, this becomes cosine squared theta. So the square root becomes 2 cosine theta. So this becomes 2 square root of 3 integral of 2 cosine theta times cosine theta d theta. Remember, whenever you do trigonometric substitution, the radical, this term here, should simplify to a trigonometric expression that is free of the radical. It should be a square or something. Okay, moving on. This becomes, I'll factor out the 2 again, so this becomes 4 square root of 3 integral of cosine squared theta d theta. Cosine squared, we integrate this by using half angle identity, the power reduction. So this becomes 1 plus cosine 2 theta over 2 d theta. I'll just take this out. 1/2 times 4 square root of 3 is again 2 square root of 3. So 1 plus cosine 2 theta d theta. Okay, this one we can integrate easily. This one, we use a substitution equals 2 theta. Then du is equal to 2 theta, 2 d theta. So I'll take out the factor of 2 here. And then I'll just skip to the answer. The answer is 2 square root of 3, this is theta, plus this is sine 2 theta over 2. That's because this becomes integral of cosine u, and the antiderivative of cosine u is sine u, and then you have the 1/2 here, so it's factor of 1/2 here, plus c. Are we done yet? No, because this is in terms of theta. We want our answer to be in terms of x. So the next step is to write this in terms of x. So we have the integral equal to 2 square root of 3 theta plus sine 2 theta over 2 plus c. Okay, the substitution was x is equal to 2 sine theta. This is in terms of theta, this is in terms of 2 theta. That's not good. So what we should do is to write this in terms of just theta. And by properties of, by the double angle identity, that's 2 sine theta cosine theta over 2. This cancels out. So that leaves you with 2 square root of 3 theta plus sine theta cosine theta plus c. This one we know because it's x over 2. Okay. This one we know too, because if sine theta is equal to x over 2, then theta is equal to the sine inverse of x over 2. Sine inverse of x over 2. So what remains is cosine theta. To solve this, generally, it's easy to use a right triangle to represent the substitution. So if x over 2 is equal to sine theta, then by the mnemonics we have, it's so opposite over hypotenuse. So if you do a right triangle here, your angle being here, the opposite angle, the opposite side of the angle is labeled x, and then the hypotenuse is labeled 2. This is the adjacent, and is equal to, by the Pythagorean theorem, 4 minus x squared. So by the SOHCAHTOA again, cosine theta is equal to adjacent over hypotenuse. So the adjacent is this, the hypotenuse is this. So this is equal to square root of 4 minus x squared over 2. Yay! So the answer is 2 square root of 3 times sine inverse of x over 2 plus x square root of 4 minus x squared over 4 plus c. If you want, you can distribute this to these two terms. It's up to you, but I leave that up to you because this is already fine. Okay, next, item number 23. We are asked to evaluate the integral of secant to the 5th x tangent cube x dx. So, when you have something in terms of secant and tangent, a good first step is to try to write everything in terms of secant or tangent. What I mean is, you try to use substitution u equals secant x. So the derivative of this is secant x tan x, or u is equal to tangent x. The derivative of this is secant squared x. If you can do either of this, then that gives you a very decent substitution. If you don't want this, you can write everything in terms of sine and cosine. That should work too, but maybe longer. For this case, if we let u is equal to secant x, we'll get left with secant to the 4th x times secant x tan x times tangent squared x. Note that I've isolated the secant x tan x for the derivative. This works well because the tangent squared can be expressed in terms of secant squared, which is secant squared x minus 1. So the substitution we should use is u is equal to secant x. Suppose we want, if you insist, let's try to use u equals tan x. If we use that, we have to isolate the secant squared. So secant squared x, so we're left with secant cube x, then tangent cube x. The problem is we cannot write this simply in terms of tangent because the power is odd. So this is a no. We use this representation. So this becomes integral of secant to the fourth x tangent squared x times secant x tangent x dx, and then let u is equal to secant x du is equal to secant x tan x dx, which is this expression here. And then again, we express this in terms of secant squared x minus 1. So everything turns out to be u to the fourth times u squared minus 1 du, which is quite simple. When you distribute the u to the fourth, u to the 6 minus u to the fourth du, and it's equal to u to the 7 over 7 minus u to the 5 over 5 plus c. Writing everything in terms of x gives you secant to the 7 of x, 7 minus secant to the 5th of x over 5 plus c. Done. Next, the second to the last item number 24. Whoops, the camera moved. Number 24, it's the integral of negative pi over 4 to pi over 4, 1 over 1 minus sine x dx. Okay, you see, this is negative to positive. So the first thing you have to do is to check if the integral is odd or even. If you substitute negative x here, it becomes 1 plus sine x. Clearly, it's not odd and it's not even either. So we can't use that trick. So what we do is, we multiply by the conjugate, which is 1 plus sine x. 1 minus sine x times 1 plus sine x over 1 plus sine x. This becomes negative pi over 4 to pi over 4, 1 plus sine x over 1 minus sine squared x dx. This is cosine squared x. So this becomes negative pi over 4 to pi over 4, 1 plus sine x over cosine squared x dx. So we split again. This is negative pi over 4 to pi over 4, 1 over cosine squared x dx plus sine x over cosine squared x negative pi over 4 x. This one is equal to secant squared x which we know the antiderivative of. This is tan x. So we have to evaluate this from negative pi over 4 to pi over 4. So that's tan pi over 4 minus tan negative pi over 4. 1 minus negative 1 is 2. That's one part. So it's this part. Next part. This one is negative pi over 4 to pi over 4 sine x over cosine x times 1 over cosine x dx is equal to negative pi over 4 to pi over 4 tangent x secant x dx. This one we know as well. This is secant x. So this one becomes secant x evaluated from negative pi over 4 to pi over 4. So this is secant pi over 4 minus secant of negative pi over 4, which is equal to, this is equal to square root of 2 minus square root of 2, so 0. So the answer is 2. Okay, actually it's not necessary to do this part because I should have checked this, because this is sine x over cosine squared x, so this is odd, this is even, so even odd divided by even is still odd, so they should be equal to 0 straight away. So I wasted some part of my scratch paper. Anyway, the answer is 2. For the very last item, the integral of dx over x squared of x squared minus 2. So this one, again a trigonometric substitution. This being in the form x squared minus a squared. So we'll use a substitution. X is equal to a being square root of 2, secant theta. So dx is equal to square root of 2, secant theta d theta, secant theta tangent theta d theta. Ooh. And then this one becomes, I'll just skip ahead, this one is equal to square root of 2 tangent theta. You can do what we did earlier with the sign substitution. Essentially, it should turn out to be this simple. So again, this one becomes square root of 2 secant theta tangent theta over x is square root of 2 secant theta times square root of 2 tangent theta. This cancels out, this cancels out, this cancels out, cancels out. So we are left with 1 over square root of 2 integral of d theta, which we know to be equal to theta over square root of 2 plus c. In terms of x, from here, we know that x square root of 2 is equal to secant theta. So secant inverse of x over square root of 2 is equal to theta. So this one is 1 over square root of 2 of secant inverse x over square root of theta plus c. Okay, actually, this is already one of the most common forms for inverse trigonometric integrals. So the form is dx over x square root of x squared minus a squared. The answer is straight away 1 over a secant inverse of x over a plus c, which is that. So if you know this should help you to easily solve this within a few seconds. So that's it for this video, and actually that's it for this series. I hope you learned something, and we'll try to do as well the 2014 and so on contest. Let's see. Anyway, goodbye. Thank you for watching.